Gemma 4 just got up to 3x faster. On a consumer GPU, the 31B model now hits 24 tokens per second. That's real time chat from a model that used to crawl. But here's what nobody's asking: does this actually change what model you should run locally? Or is Qwen 3.6 still the smarter pick? Here is the map for this video. First, we will talk about 3x faster, then we will move to drafter plus verifier speed. After that, we will cover not ALL speedups are equal. After that, we will cover from 8 to 24 talk or S. After that, we will cover speed or compatibility. Finally, we will close with waiting vs flowing. 24 tokens per second from a 31B model on a single consumer GPU. A month ago, that was science fiction. Google dropped multi-token prediction drafters for Gemma 4 on May 5th, and the headline number is a 3x speedup. But let's get specific, because a 3x faster means nothing without knowing the starting point. On an RTX 4090, the Gemma 4 31B dense model went from generating around 8 tokens per second to roughly 24 tokens per second. That's the difference between a model that feels broken and one that responds faster than you can read. For the smaller models, the numbers get even crazier. On a Pixel phone, the E2B model hit 3.1x faster and the E4B got 2.8x. But here's the first caveat you need to know: this isn't a flat 3x everywhere. On Apple's M4 Silicon, the same 31B model saw 2.5x speedup, still massive but not the headline number. Why memory bandwidth? The M4 first unified memory is fast, but it's not dedicated RAM. The drafter model needs to share that bandwidth, so the multiplier drops. This matters because a lot of you are running on MacBooks, so is it real? Absolutely. Is it exactly 3x on your specific machine? Probably not, and that's the first thing to understand before you benchmark this yourself. This isn't a faster GPU or a smaller model. It's a completely different way of generating text. So how does this actually work? Because if you're going to use this, you should understand what's happening under the hood, not the math, but the logic. Normally, a language model generates one token at a time. It looks at the context, predicts the next word, adds it to the context, and repeats. That's slow because each step depends on the previous one. You're bottlenecked by memory bandwidth. The GPU is waiting for data more than it's computing. Google's approach uses something called speculative decoding. Here's the idea: if you pair your big smart model, say Gemma 431B, with a tiny fast drafter model, the drafter is trained to predict multiple future tokens in one shot. It's not as accurate as the big model, but it's fast, really fast. So while the big model is busy processing one token, the drafter jumps ahead and guesses the next 3 or 4 tokens. Then, and this is the clever part, the big model verifies all of those guesses in parallel. If it agrees, it accepts the entire batch in a single forward pass. It even generates one extra token of its own in the process. The drafter also shares the KV cache with the target model. Think of the KV cache as the model's working memory. All the context it's already processed. The drafter doesn't have to recalculate any of that. It just reads what the big model already figured out. That's a huge efficiency win. The result: you get the exact same output quality because the big model is still the final authority, but it arrives way faster. Zero quality degradation, just speed. The 3x number is real, but it's not uniform. And if you're on the wrong hardware, you might be disappointed. Not every Gemma 4 model gets the same boost, and not every hardware setup sees the full 3x. Let's break down who actually wins here. First, the smaller models, E2B and E4B, see the highest multipliers on mobile devices. We're talking 3.81x and 2.8x on Pixel phones. That's huge because it makes on-device A actually usable for real-time tasks. Voice assistance, live translation, that kind of thing. The larger models, the 26B MoE and the 31B Dense, are where things get interesting for desktop users. On an RTX 4090, the 31B hits that 24 TOC or S number on an RTX 3090. You're looking at closer to 15 TOC or S, still very usable for a coding assistant or a chatbot, but not quite real-time conversational speed. Now hardware. NVIDIA GPUs with lots of RAM benefit the most because MTP needs extra memory for the drafter model. We're talking roughly 20% more RAM usage. So if you're already tight on a 12GB card, this might push you over the edge. Apple Silicon gets a solid boost 2.5x on M4, but the unified memory architecture means the drafter and the target model compete for bandwidth. It's still a win, just not the full win. Here's my honest take: if you're on an RTX 3090 or 4090 with 24GB, the 31B with MTP is now a genuinely good local model. If you're on a 12GB card, stick to the 26B MoE. It activates only 4B parameters at a time and plays much nicer with limited RAM. And if you're on a MacBook with M4 Max, the 31B will work, but expect that 2.5x multiplier. Still fast, just not "I can't believe this is local" fast. 15 tokens per second on a 3090, that's the number that changes whether you can actually use a 31B model as a... Let's put concrete numbers on this because faster is vague. Here's what you can actually expect on common hardware based on Google's published data and reasonable estimates for setups they didn't explicitly test. On an RTX 4090, the Gemma 430 repeats around 24 tokens per second. For context, the average person reads at about 10 to 15 tokens per second. So 24 TOC or S means the model is outpacing your reading speed. That's the gold standard for chat. You're never waiting. On an RTX 3090, expect roughly 15 tokens per second. That's right at the threshold of reading speed. For a chatbot, it's fine. For a coding assistant where you want instant completions, you'll notice a slight delay, but it's totally workable. On Apple M4 Max, we don't have an exact number from Google, but applying the 2.5x multiplier to the baseline suggests something in the 18 to 20 tokens per second range. That's solidly above reading speed. Good experience. On a mid-range laptop GPU, think RTX 4060 mobile or similar, you're probably looking at 8 to 12 tokens per second. That's usable for occasional queries, but for anything interactive, you'll feel the lag. This is where quantization becomes your friend. Here's the key insight: the MTP speedup shifts what's usable down the hardware stack. A 31B model on a 4090 used to be borderline. Now it's comfortable. A 3090 used to be too slow for 31B. Now it's viable. That's the real story, not the number itself, but what it unlocks. Quick aside, if you study from your own notes, try Memonique. It turns PDFs, slides, and recordings into summaries, mind maps, flashcards, quizzes, and exam practice. The free plan is enough to test the workflow. Link in description. Then we go back to the video. Gemma wins on speed, Qwen wins on compatibility, and which one matters more depends entirely on what you're Now the comparison you came for, Gemma 4 with MTP versus Qwen 3.6 consumer versions. And I want to be fair here because these models are competing for the same slot on your machine. Let's start with what Qwen 3.6 brings to the table. Qwen's consumer versions rely on traditional quantization, 4-bit, 8-bit, to fit on consumer hardware, no speculative decoding, no draft models. That means the speed is whatever the base model can do on your GPU, period. On similar hardware, a quantized Qwen 3.6 model might run at 10 to 15 TOC or S perfectly usable, but not the 24 TOC or S Gemma can hit with MTP. But Qwen has advantages that don't show up in a speed benchmark. Compatibility is the big one. Qwen models work out of the box with basically every inference engine, Ollama, LMM Studio, Llama, CPP, you name it. MTP drafters require specific support. As of right now, not every framework has implemented it. If your workflow depends on a particular tool, check compatibility before you commit. Ease of setup is another factor. Quantization is a solved problem. Download a GAF file, load it, done. MTP requires you to load two models, the target and the drafter, and configure them to work together. It's not rocket science, but it's an extra step. Now, quality. Both models are frontier class for their size. Gemma 431B has an estimated Amrina score around 1452. Qwen 3.6 as exact numbers aren't in the evidence I have here, and I'm not going to invent a comparison. What I can say is both are in the same tier. You're not sacrificing intelligence either way. So the trade-off is real. Gemma gives you speed via MTP. Qwen gives you compatibility and simplicity. Which one wins depends entirely on your setup and your patience for tinkering. Speed numbers are abstract until you map them onto actual workflows. So let's talk about what this means for the two biggest local use cases, coding assistants and chatbots. For a coding assistant, speed is everything. When you're writing code, you're in a flow state. You type, the model suggests, you accept or reject, you keep going. If the suggestion takes 2 seconds to appear, you've already moved on mentally. The flow is broken. At 12 TOC or S, a multi-line completion might take 2 to 3 seconds. At 24 TOC or S, it's under a second. That's the difference between an assistant you use and one you ignore. For a chatbot, the bar is lower if you're having a conversation. So, which one are you running? Gemma 4 with the MTP speed boost? Or are you sticking with Qwen 3.6 for compatibility? Drop your setup and your choice in the comments. I read every single one. Links in the description. See you in the next one. If this helped, like the video, turn on the notification bell and comment what you want next. New practical AI breakdowns every week.